So in this video we will try to understand the number systems in computer, and this is very important because while I was telling about the ones complement, addition and subtraction of binary numbers, I felt that many of you might not have even aware of what these binary numbers are and what this number system means. In a very simple way, I will try to make you people understand the number system in computers. So the most common number systems are the decimal. Let's say like decimal. This is what we use in our daily life. Its base is 10. Then the another one is binary. Its base is 2. The another is hexadecimal. Its base is 16. And then we have octal number system. Its base is 8. Here the B means base. I have written a very short form. So we have 4 number systems: decimal, binary, hexadecimal and octal. Let's talk about first the decimal one. So decimal number system is one what we use in our daily life, like 1 2 3 4 5 25 26. So like suppose we have this number 25. For the decimal the base is 10. Okay, so we'll represent this 25 as this. Now how this comes is like, when this is the number, okay, we will give, you can say, a position to this digits, or we can say the significant bits. So this comes at 0th position, this comes at 1 position. Its base is 10. So what we will do is 2 into 10 ki power 1 plus 5 into 10 ki power 0. 5 into 10 ki power 0 is equals is 10 in ki power 0 is 1. So 5 into 1, and this becomes 20. This will come 5, this will become 20. So this it comes like 25. Let's talk about the binary one next. Okay, so this is what we are using daily life. Binary number is something that is mostly used in computers, right? For any digital system. So you can say on, off, true, false, or 1 or 0. So binary is mostly used in computers. Let's talk about, suppose you have one binary number which is 1011. Okay, we'll represent it as with the base 2. Now if I have to convert this binary number into decimal number, let's give it a position. So this would be, you'll always start from the right. So this is your right, this is your left. It will come as 0 1 2 3. Now if I have to convert this binary number into decimal number, we know that the base is 2. So what we'll do is 1, I'll take this 1 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. We'll multiply these digits with base and the power with the position of that number. Now I'll convert 2 power 3 is 8. 0 into 2 power it will be 0. 1 into 2 power 1, this will be 2, and 1 into 2 ki power 0 is 1. 1 into 1, it will be 1. So this binary number in decimal form is 11. You can also write it like this. Now there are certain operations that we perform on the binary numbers, which I have also discussed in my last video where I was telling about 2's complement. So the operations that we perform on these binary numbers is addition, subtraction, multiplication and division, which we normally perform on our even in maths, right? So these are the basic operations that we perform. So you might also get a questions like, okay, this is a binary number, these two are the binary numbers, and you have to do the binary addition. Now you have to know the rules of the binary addition. So for, like as I said, in binary numbers we have only two numbers, 1 and 0. Okay, so the addition rules for the binary addition is like 1 plus 1 will be 1 0, where you will write the 0 and will carry forward 1 if there's a value in the next column. Like suppose if there's the number is like this 10 0 1. Okay, so here 1 plus 1 is 10, so you'll write 0 and will carry forward this 1 on the next column. This is the rule 1. Second is 1 plus 0 is 1, 0 plus 1 is 1, fourth is 0 plus 0 is 0. So this is the binary addition rule. Let's talk about the hexadecimal number system. So when it comes to hexadecimal number, its base is 16. In hexadecimal number system, we represent values from 0 to F. Now what is this? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that we start A, B, C, D and F. So from here till here you can represent in the form of a binary number. Like for example, if I say for the 2, so the binary representation for the 2 is 1 and 0. But in because the base is 16 here, the numbers mostly are represented in the form of 4 binary digits. So like if I am representing 2 for the in hexadecimal number system, I'll write it at 0010. Same for if I say for 7, if it's 111, I'll write it as 011. Now you might be thinking like from where I get to know that this is 111. So let's take 7. Okay, if I have to represent 7 in a binary digit number system, what I'll do is I'll write 7, then I'll convert it into a binary number. So you might have read about LCM and SCF in your maths. So 2, 3, 6 will get a remainder once 1. 2 once 2 will get a remainder 1. Now I'll count from here to in this way, in this direction. I'll write 1 1 1. So this is the binary representation for the 7 decimal number. Same will do also for the 8. So like if you want to know what's the binary representation of 8, we'll do the same. We'll take the HCF, or you can say like you take a division. So I'll do 2 4s 8, we'll get a remainder as 0. You write remainders on the side. 2 2s 4, remainder 0. 2 1s 2, remainder 0. Now I'll count in the upward direction. So the binary representation for the 8 is 1000. For A we'll always write 10. For B we'll take the number as 11. For C we'll take it as 12. For D we'll take it as 13. For E we will take it as 14. For F we will take it as 15. So let's talk about one thing. Suppose you have given a number as 183 and they say you to convert it in a decimal number. So what you'll do is, if any number is written like 1A3, so this is an hexadecimal number. You need to be aware of this thing, that if any number is written like this, we have one character, so this is a hexadecimal number. And if they are the question says that to convert in a binary decimal number, you have to convert a hexadecimal number into a binary number. So because it's a hexadecimal number, the base will be 16. So 183. In the same way as we have written the positions here, we'll write the position 0 1 and 2. 1 into base 16 power 2 plus A into base 16 power 1 plus 3 into 16 base 0. For here 16 square, we'll write the 16 square, which is 256. 256 into 1, 256, plus for A we'll write as 10 into 16 power 1. 16 power 0 is 1. 3 into 1 is 3. To 256 plus 160 plus 3, the number comes like 419, and this is a decimal number. So if the question says to convert a hexadecimal number into a decimal number, this is what you will do. And if number comes like 3EF, you write the position, you'll write 3 into 16 square plus E into 16 power 1 plus F into 16 power 0. At the position of the E, you will take the number as 14. At the position of the F, you will take the number as 15, and then you do the same. So this was all about the binary, the decimal and the hexadecimal number. Let's talk about the octal. For the octal number, the base is 8. And when we say octal, so in this the number is represented in the form of the 3 bits. So like for example, I say like if I represent number 2, okay, so we know the binary number system for the 2 is 1 0. Now if I have to write in the form of the octal, I'll write is at 0 1 0. So you can say like octal numbers have 3 bits like 0 and 1. For the hexadecimal, we have 4 bits number. We represent in the form of the 4 bits. For the binary, we represent in the form of 2 bits. This is the like you can differentiate how we represent an octal and a hexadecimal number. And in octal, we represent numbers from 0 to 7. If you count from 0, 1, 2, 3, 4, 5, 6, 7, the total number of digits that comes under octal is 8. And if you count under the hexadecimal from 0 to F, the total number of characters that comes under is 16. And for the binary, we have 0 and 1. For the decimal, like for the 10, 0 to 9 is all what comes under the decimal numbers. So if you forgot like what's the base of these numbers, you can like just remember in the form of this thing, that the numbers that comes under octal is from 0 to 7, and we can represent only till 7 in the form of 3 bits. Like after 7 you get 4 bit binary system. Like for 8 it's 1 0 0, for 7 it's 1 1. So only till 7 you can represent in the form of 3 bits. So it comes under the octal number system. So you might be thinking like why we are even learning this. So there could be a questions where they might ask you to like convert octal to binary. If the question comes like octal to binary, so if suppose this is a octal number because it's 3 bit, okay, or even if the number is like this long, right, and they say that this is the octal number, or if they have given you the base and they ask you to convert it in the form of a decimal number, you'll make a group of 3 bits and will convert it into the individual decimal number. So like if I say that 000, it's a binary equivalent of 0. If I say 011, it's a binary equivalent of I guess 6, I guess, okay. Here also it's 6, here also it will also come at 6. So you have to make a bit of 3 binary digits if it's a to convert octal to decimal number. So the question that could be asked is like conversion of what? First, like decimal to binary, or binary to decimal, hexadecimal number to decimal, or vice versa, like decimal to hexadecimal and binary to hexadecimal. And if comes like you have to convert a binary number into as a hexadecimal number, so as I said, like if suppose there's a number like this one, okay, and they say that this is a binary number converted to a hexadecimal number, then you will make a group of 4 bits because it's hexadecimal number. If like as you see this, these 2 digits is left alone, so you'll add 2 zeros to it on the left hand side, not on the right hand side, on the left hand side of the number. So this is the group, this is your right side, this is your left side. You have to add 2 zeros on the left hand side, and then you will find like what is the binary equivalent, decimal equivalent of this number, and then you'll add it. So this is how you convert a binary to a hexadecimal number. And the another conversions could be like decimal number to octal, or binary to octal, octal, 2 binary. If you want to know about like how we can do this, want the rules, let me in the comments. I'll try to give you the notes of these things. Else I think if you understood it, it's fine, and if you are able to like pick up the questions and you are able to solve it, just solve it.